Hello, welcome back. Our next presenter is Ron Macnaughton from the Toronto Centre, and he'll talk to us about how ancients predicted eclipses.
Eclipses are so fascinating. There are just so many aspects to it. And I'd heard about ancients predicting eclipses, and it seemed like something that I wanted to look into. And I'm lucky to have a group that will listen to what I found out because it's quite interesting to me. Didn't take long searching for this to hear about the total solar eclipse of Thales. And the reconstruction of the most likely eclipse is this one, if I can get the mouse working. And it goes from the Pacific off Central America. The greatest eclipse point is somewhere near Bermuda in the Central Atlantic. And then sunset would be somewhere around the edge of Europe, Turkey, whatever. Herodotus was born a century after this event, and it's sort of like me writing a story about the Fathers of Confederation gathering in 1864 and reading from local newspapers what happened. I mean, it's well past his time, but he did a lot of research and put things together. I've put all the words of the account, but it's rather wordy, so I'm just picking out the key things. There was a war between two cities that lasted over several years. And the quote is, "Just as the battle was growing warm, day was on a sudden changed into night." Now I remember one thunderstorm where the clouds were green, and I was terrified and herded my whole family into a small room downstairs where we'd be safe if a tornado hit us. And after a few minutes, the sounds disappeared, so we went up. And a few minutes later, we heard sirens of emergency people going to rescue people that were injured during the eclipse or during the tornado, which missed us. Anyway, after this event, because people those days thought that if something astronomical happened, it's probably caused by gods or whatever, and so they did make peace. Oh, wrong way. Pardon me. There. The account continues. This event had been foretold by Thales, who was from a third city, and he told somebody in a fourth city about it. And that sounds pretty impressive. But then it said, press the wrong button, pardon me, fixing for it the very year. Now, is that really a prediction of a total eclipse? And it reminded me of something that a very famous philosopher said when a punk pulled a switchblade on him, and Crocodile Dundee said, "That's not a knife," in his Australian accent. Well, to me, if you're predicting during the year, it's not a total eclipse, total solar eclipse prediction. To me, and I don't know of any official definition of this, but basically you need a date and a location of totality. Basically, what would be needed to eclipse chase? And I don't see that from there. Here's an example of one. That's the one we're about to come up in a couple of months. So it starts in the Pacific Ocean. The greatest eclipse is in Mexico, and it goes tantalizingly close to Toronto, but not quite good enough. And we all hope for good weather. I'm with a group that's planning to drive south, and we're hoping to find a place with good weather somewhere, but who knows? Now, a total eclipse is only visible on a tiny fraction of the Earth each time, and there's almost a 1 in 400 year return period to pick up an eclipse, although some places like Carbondale in southern Illinois is going to experience 2 within 7 years. Basically, no ancients predicted a total solar eclipse in terms of my definition. But they could very easily predict lunar eclipses that cover half the Earth, and they didn't do a bad job predicting partial solar eclipses. I want to go back to early religion. There were groups of people called priests, shamans, astrologers that explained to people that what happens in our lives are influenced by supernatural things, and often the supernatural things were astronomical objects. And can you imagine the incredible um, emotion when something happens to the moon or the sun? And I have an example of that. I read that a scientist flew down from, to Mexico, to the Yucatan, and she billeted for several weeks with a Mexican science teacher whose ancestry were Mayan. And what happened is the two ladies had wonderful conversations. It was just a magical time for both of them. But then a lunar eclipse came along. And I'm sure the science teacher copied the same diagram about eclipse shadows that I did, and probably most of you did in school. But she had rank terror on her face. And this shows that the whole concept of eclipses are a lot deeper for some people, and especially before science got good explanations. I'm going to wander a bit into the science of eclipses. The plane of the Earth's orbit around the solar system, sometimes called the ecliptic because that's where eclipses occur. The lunar orbit tilts about 5 degrees to that. And for part of the orbit, it is above the plane in terms of northern being up, which Crocodile Dundee would disagree with, and sometimes below. And the key is that we call this the ascending node, where it goes up, and descending. And that's when eclipses showed. So I put a little white dot there to represent the moon, although it would be dark in that situation. And then April 8th, 2 months and a day from today, there's going to be a magical solar eclipse. And it's going to be in front of the stars of Pisces. And if there happened to be a lunar eclipse on the same day, which of course there won't be, the lunar eclipse would be in front of Virgo. Where's the right button? Here. In 3 lunar cycles time, now the moon's orbit is pointing roughly the same way, but you see the moon is well above the plane of the of the Earth's orbit, and there are going to be no eclipses. But after another few, you get eclipse season again. And I wrote that there's going to be 1 lunar and 1 solar eclipse somewhere, and I found twice in the next century there ends up being no lunar eclipse. So I'm slightly wrong there, but I noticed that after it got in the slides. And of course, after 12 cycles, lunar cycles, you end up just a few days short of a year. And in some cultures, like in Babylon, they had a lunar eclipse, but the king could say, oh, we're getting out of cycle, and we'll just add an extra month. And some cultures do it, some don't. The problem is, if you want the month to tell farmers when to plant, you want something that goes on the solar system and the solar, schedule. Anyway, that's there. Now, if the moon were only affected by Earth's gravity, the sun's a long way away, it doesn't matter, right? Then every eclipse would be in Virgo or Pisces, because if a body is by itself in orbit, it just keeps going the same way. The only problem is that the sun also affects it, and for reasons I can't explain, it causes the line of nodes to bend backwards by 19 degrees a year. And I scaled this, so these are actual 19-degree bends, although that would be at the view from the top. And it turns out the eclipse season is every 5.8 new cycles, so sometimes it's 6 lunar cycles, sometimes 5. And this is part of complex patterns. Also, there's a perigee pattern that perigee pattern that I'm not talking a lot about, but that affects whether it's total or annular. By the way, the perigee for our eclipse coming up in 2 months is the day before. So it's going to be close to closest, which is why we get 4 minutes of eclipse and we're in the right place. Anyway, there are all sorts of patterns, the way these cycles interact. And more than 1,000 years, Babylonians knew those patterns. It turns out the kings in Babylon, there was a belief that they must not be exposed to the light, the red light from a lunar eclipse. So there are all sorts of walkarounds. If there was a lunar eclipse coming, sometimes the king would hide and appoint somebody else to take his roles, and the person would say, "What did I do to deserve this?" Then after the eclipse, the king would take over and execute the guy, and just as before, he'd say, "What did I do to deserve this?" Anyway, because of that, the kings really wanted to know when eclipses were coming. So they funded the whole priests, astrologers, whatever you call them, that monitored things. And the Babylonian, I call them astrologers because the goal was not pure science. And they kept records on clay tablets like this one, cuneiform. And they had special events like eclipses and comets, but also details of the moon events, not just eclipses, but when the moon rose or set compared to the sun and different patterns. And I tried to find out if they measured the azimuth, because to me it would be very easy to have a specific place the observer stands. And when the sun sets, they have a set of degrees marked around it. And when the sun sets, that's one of the things they record about it, and the moon set. And that would tell a lot. And I tried to find out if that was part of it, but I couldn't. I'm still working on it. And Babylonians found that there was a repeat 18 years, 11 days, and 8 hours, roughly. And it's Edmund Halley that called it a Saros. It's more than just eclipses that have that pattern. The whole cycle of how the moon moves has that period, and is that cycle that was determined. Now, the modern explanation is that 223 new cycles is a certain number of days. A larger number of node cycles is almost the same. And a intermediate number of perigee cycles is almost the same. So when you have one Saros, you almost have every major property of the moon back to where it was. Not perfectly, but it's close. The Antikythera mechanism, that's found in a boat, and on it was printed 223. 223. So the people that made that knew of the Saros cycle, what we now call the Saros cycle, and it was part of it. I'm going to give you an example of total eclipses in the same cycle. I have a friend who went and watched this eclipse in 2006. It started in the Atlantic, just off Brazil, a little south of the equator. The greatest eclipse was in Libya. There are some people, I think, from this center that saw it in the desert of Libya. Did anybody here see the eclipse there? I think some Toronto Center members were, maybe not. A friend of mine was in Turkey, and he saw it. It was cloudy most of the time, but he had good luck on the actual moment, the only moment that matters. And then it went into the stands. Now, I just want to compare that to our eclipse in 2 months. Also starts a little below the equator, goes up. Central, the greatest eclipse is at roughly the same latitude. And it goes on to, actually, people in Ireland will be able to see the partial eclipse at the end. But there's a difference. But look at the 8 hours. And the Earth spins counterclockwise like everything else, and it spins in 8 hours 1/3 of the trip around the Earth. And 1/3 goes from about Central Africa to Mexico. In 2024 or 2042, there's going to be another eclipse, 18 years, and it's going to be somewhere off. It goes through the Philippines, and it's mostly over water by China. Another 18 years, it's going to take it from there to almost a repeat of this one. The greatest eclipse point is still going to be in Libya, all right? And it's going to be almost the same. So when you have 3 Saros cycles, you get an almost repetition. And that's called an exoligmos. Not sure I'm pronouncing it correctly. And it turns out that many people think that that's the most important identifier or property of solar eclipses, much more than the Saros that gets all the publicity. Now, I just want to admit, when I was younger, I was really stupid. I was at university, and some friends came to me and said, "Do you want to join us driving down to Virginia and watch this eclipse?" And this stupid idiot said, "I have an assignment to finish." Anyway, they came back clear. They saw everything. They were just glowing. Anyway, I think another reason I didn't go is I didn't want to be part of a Carly Simon song about "You're So Vain" because she talked about somebody flew a Learjet near Nova Scotia. Anyway, that is an exoligmos from the eclipse that we're going to see. See, it's the same shape, a little bit wider. This eclipse is a little bit wider. The greatest eclipse point when the moon is new, when it's noon, is in Mexico again, and it's roughly the same shape. And if you predict that there's an eclipse on a date, there's a very good chance that 54 years and 33 days later, there's going to be another solar eclipse, but you can't tell exactly where totality is. And there's also going to be the same pattern for lunar eclipses. And I looked at the pattern of eclipses for this century, about 200 cycles of them. And there's so many examples where it's 54 years and 33 days and some not. But, no pattern is perfect. But in terms of ancients predicting eclipses, this pattern, once it was discovered, was very good at predicting lunar eclipses and partial solar eclipses. But totality, not so much, because totality is narrow. And there are a few places where you get totality in the same place twice, but usually it's either above or below, and they're complex patterns that make it. But if you had a country or an empire the size of Mexico, there's a good chance if you have one solar eclipse, total solar eclipse in your empire, there's a pretty good chance that 54 years later, you're going to have another one somewhere else in the empire. So that's to this stage they found patterns. So good lunar eclipse predictor, not so for totality. Now we get to Greek astronomy. They used Babylonian records, and they worked on improving mathematical models. And you know what? There's a name for something where you take a whole bunch of observations and then you make mathematical analysis of it. And that's called science. And some people argue that astronomy was the very first science that was ever done. I can't tell for sure, but definitely these people were doing science, even though the purpose was to make sure kings don't get exposed to the light, the red light of a lunar eclipse. Hipparchus, a few years before in BC, was from Nicosia, and all his books are lost. It's sad, and for some reason, Europeans in the Dark Ages loved burning libraries. I don't quite understand it. But it could be the book will be recovered. And I just read an article yesterday in The Economist, although I'd heard about this before, that they found a technique where they can take a scroll in a library that was underneath the Vesuvius mountain and the hot gases spewed down and killed everybody but one guy in a prison. And it turns out that there are a whole bunch of documents that are fragile, but there's a process where they can fire X-rays or something at this and computerly analyze it, like what's it called, where they can work out the shape of something with multiple. Yeah. Anyway, that's it. And there's a technique that's being perfected, and it could be one of these scrolls, maybe this one, is going to be the book from Herodotus, not Herodotus, but Hipparchus, that's there. Incidentally, he's got a space mission named after him. The other major Greek guy is Ptolemy, and there are allegations that he kind of fudged a little data, and to my knowledge, there's nothing. There are no space missions named after him. But his book, Almagest, refers to books by Hipparchus, and it was the #1 book for astronomy for 1.5 millennia. Like, that was the authority, and what he said was obviously true, right? So, there are two assumptions in Greek models. By the way, the Mayans also believed that everything moved around the Earth. And you have the moon, and then you've got further circles. They also included Mercury, Jupiter, and Saturn, although that's not shown in this diagram. And these things move around the Earth, and there's a general cycle that everything rotates around the Earth every 24 hours. Then there are other cycles on top of that to go the relative motion of these things. The second assumption was that everything moves in circles and they all have uniform motion. So the sun moves evenly compared to the center of the movement. But there's a problem. It's easy to measure the solstice, the winter and summer solstice, by either measuring when the shadow is shortest at noon or when it sets furthest north or furthest south. The equinoxes are a little harder to measure, and there was reference to a bronze ring in Alexandria where it's completely flat and it's pointed where the perpendicular to the circle points to the North Celestial Pole. Then any star, like the belt stars in Orion, when they shine down, a cockroach on this side couldn't see the stars of Orion because it would be blocked, or the stars of the belt of Orion, because they're on the celestial equator. And most specifically, there's a relatively nearby star. When it reaches equinox, it casts a shadow from this side to that side, and by carefully looking at the shadow, they could get the equinox time within a few hours, and they keep repeating it over many years, and they get accurate values. I tried to find out where this thing is, but on equinox, it would be interesting to see what happens to the shadow. And just at the last second, I found this thing from Beijing in China. And if this surface is perfectly flat and the other is perfectly flat, and the gnomon, the metal pointer for the sundial, were it pointed exactly to the celestial pole, you would see funny patterns on the actual moment of equinox. Anyway, the season lengths are not the same. Summer's longest, winter's shortest, which is nice for us, but not so nice for Crocodile Dundee. So the solution is, well, maybe the sun makes a perfect circle in constant motion, but it's offset or a little eccentric from the Earth, and that you get the right balance. I mean, I showed it too far, but I'm just trying to show that you can make it that the number of days match. And I always assumed these were just pretty diagrams. But it turns out 60.8 days is 1/6 of a year. So in that time, the sun would move, compared to everything else, 60 degrees. Okay? But probably a high school student in trigonometry in grade 12 could probably figure out, if they knew that the Earth's fixed elevation is 15 degrees left or towards the winter solstice of the sun, and maybe it's 5% north of the overall, they could probably calculate that it's 57 degrees. And this is the sort of thing that the Greeks did, and they could make predictions. And those predictions were valuable because astrologers could say, in June 17th, Jupiter is going to close to Regulus in Leo, and that means kings have to be very careful not to start any battles then, or whatever astrologers predict. I like to think they often say, you're going to make a tall, dark, and handsome guy or gal, and but on this date. But anyway, I don't know about astrology. I'm not a big believer in it. For other things like the moon and the planets, they had circles upon circles upon circles, and that's called epicycles. And they made tables with predictions for navigators. And I'm going to show one example, also for astrologers. And every navigator would have, because there's all sorts of information that's useful for navigation, including Christopher Columbus. And he sailed the ocean blue in 1492, or whatever order it is. But this would be, 12 years after. And he sailed from Spain. Probably investors paid for the trip. He stopped in Santo Domingo, and he didn't get along with the governor. And maybe the governor was afraid Columbus would take some gold that the governor wanted to get. I have no idea what the problem was. Anyway, he wandered all over the place. And I've heard two versions. One is that there was a storm that broke his masts in the sailing. And another is that worms started to eat the wood of the boat, and he limped to Jamaica, and he went as far across the shore as he could, and he landed. And out of the bush walked some Arawak Indians. And they were willing to help. And according to a book written by Columbus's son, I don't know whether the son was on the trip or not, the sailors paid for food and they got food for a while. And I don't know. Anyway, some people from the boat and some Indians paddled across to Santo Domingo to get rescued. I don't quite know how you can go through 200 kilometers of open ocean in a canoe and navigate, but they did. And they got there. And the governor said, "Nah, I'm not going to help them." And so it was a long wait. And eventually the Indians were less than happy to provide food for Columbus's crew. Where's my mouse? I've lost. Okay, there. Sorry. Um, and Columbus was worried, but he noticed that there was in the tables a lunar eclipse coming up on February 29th. Now that's our system. They were using the old system, the Gregorian system then. So what he did is he called, and it looks like it was somewhere in the middle of the night that it was supposed to finally turn. So he called Indian leadership in, and they talked about a translator, but how they could communicate this. And he talked about how his God is very powerful and very angry that you Indians are not feeding my people. And he said, the God's going to take the moon away. And according to the book, the Indians were terrified, like the Mayan ancestry lady in, just a few years ago. They were terrified, and once it was total eclipse, Columbus went into, quote, a cabin. Now, I don't know that was on the ship or whatever. And he had an hourglass, and he knew a predicted length of the eclipse, so he timed it. And eventually, he came back out, and he told the people that God is very angry at you, but he will forgive you if you feed us, and supposedly that happened. Now, I didn't mention the fact that the eclipse started at sunset rather than later on, but he was still able to pull it off according to the book. And as you can tell, the prediction wasn't that accurate, but I'm also highly skeptical that this even happened. That's the sort of story that sells books, right? And you'll notice that some stories include a particularly prurient comment that is to increase the sales. So I'm skeptical. The other reason I'm skeptical is I read some fine literature as a kid, and the comic book of King Solomon's Mines was lost or ripped up by my nephews. But I found an online source, and I bought this comic. And in this here, supposedly the hero white guys are about to be killed by a leader of some group or whatever. And they predict there's going to be an eclipse, and but we can take it away. And this guy, I don't know what his role was, but he said it will pass. I've seen it before. Well, you see an eclipse every 2.5 years of the moon, but you see an eclipse of the sun every 400 years. So it's unlikely he saw it before, but maybe he did. Anyway, the good guys or the white guys got rescued and whatever, but I'm just skeptical of the whole story. Then we come to a magical period of history in Europe. Copernicus was 20 when Columbus came back. He suggested that planets move around the sun, but he wouldn't let the book be published until he died. But he had it all ready to go, and when he died, it was published, and it was controversial. Later on, Galileo in 1609 said moons orbit Jupiter. He observed these dots that moved around, and he said they're moons. But the problem is, if everything revolves around the Earth, how can moons go around something else? Kepler, who's my scientific hero, and I'll explain more about him, he ditched the uniform circle idea. We aren't even, there are no circles in space. It's something else. And there was amazing art with Shakespeare, and these three lived for 45 years on this, they were alive for 45 years. And Copernicus was alive for almost 50 years, along with Michelangelo, the sculptor, and some guy that painted the Mona Lisa. What an amazing period of history. Anyway, Kepler was able to figure out that he was able to plot the orbit of Mars from about 20 years of data that he found out. And his first law says objects move in ellipses. And an ellipse can be made by cutting a cone, or if you make a circle inward and then you squish it, that's an ellipse. And that's the path of orbits. The second law is more important to me. And he figured out that if a planet sweeps an area in 30 days, then when it's closer to the sun, and that's why I made it such an elliptical ellipse, it's going to sweep the same area in the same time. And I think I made it a little bit big, but I'm losing my mouse here, but that's it. That allowed predictions of where objects are going to be in the future. Because if you know the parameters of the ellipses, you can predict where they're going to be, and you end up more accurate than Columbus found the prediction of the new moon, of the lunar eclipse. Newton, there's no evidence that Newton had an apple falling on his head, but two people wrote in their diaries that Newton talked to them that he saw an apple falling, and he figured it fell straight down. So whatever force caused the apple to moon came from the axe straight down. And he thought, oh, maybe that applies to the moon as well. And that's an amazing intellectual jump. Euler was one of many mathematicians that developed techniques to solve the three-body problem, because the moon's orbit depends on the Earth, the sun, and the moon, and they all interact in amazingly complicated ways. And until somebody developed those patterns and that mathematics, in my opinion, there were no clear eclipse predictions. Anyway, the first eclipse map was 1654 by Erhard Weigel, who was German. And he finished it the day before, but I think that's the map was finished. I think he knew where the greatest eclipse was, and I've made it red. Now, it seems like, well, how did he figure that out? Well, if you know exactly when the moon is going to be new, and again, you have to have accurate orbit calculations for that, that tells you the greatest eclipse point is going to be at the place where it's noon when it's the new moon. And the new moon is not a day on a calendar, but it's a specific moment in time. And he was able, from the time of the new moon, to figure out the east-west direction. Now, given that the Earth tilts sometimes with the seasons, it's not exactly longitude, but basically you could work out the east-west. Now, this eclipse, it's descending mode, so it's coming from north, and the new moon is before it crosses, then it crosses. That says that the actual latitude is going to be north of the equator. So the time between the new moon and the node gives a north-south direction location. So they could actually calculate where the greatest point of the eclipse is, and that's when you are making a total solar eclipse prediction. And to me, it took that much. Who was the first eclipse chaser? I don't know. But I wondered, who would be the richest person in the world? I thought, well, maybe it's the King of Spain, Philip. Maybe when he was a kid, he had to copy the same solar eclipse diagrams that I did and the Mayan lady did, etc. And maybe also his tutor gave him some interesting discussions of what it was like to see a solar eclipse. Like, people blown away to see a solar eclipse. Most peasants don't have the language skills to describe it, but some people would have seen a total eclipse, would have described it, and maybe he said, I want to do that. So let's say he told his ambassadors, see if you can find a place where somebody's researching this. So they would go to different universities. Let's say somebody found Weigel and found out it's going to be there. So when the word gets back to Philip, he said to his military people, okay, Operation Eclipse Chasing begins, or whatever the Spanish term would be. So they would load a bunch of horses and horsemen into ships and wagons to pull the king, and tents and whatever is needed. And they would sail through the Mediterranean. I'm not quite sure you go upstream into the Bosphorus, but they must have had people towing them by rope, by oars. I don't know how that happened. But anyway, somehow got in there, landed on Crimea, They might have camped roughly where the charge of the light brigade is, because that's it. And guess what happened? This is the modern prediction of where that eclipse would have been. And the black dot is where he was, and I think he would have seen maybe Bailey's beads, but not the total eclipse. Still an eclipse prediction, in my opinion, but I don't think Philip would have seen it. But somebody must be the first eclipse chaser, and I tried to chase that down, and I couldn't. This Eclipse Maps website, the only other one it lists is by Halley on 1715, and he predicted this, and he published it well in advance using even more modern math, and he circulated it widely because to figure out where eclipses go, you need to have observations of the moon to work out when it's a new moon. But if he could find out, people said, well, you know, I live here and I didn't see totality, but this guy here lived and did see it, he would know whether it was north or south, and that would tell him more about the orbit of the moon. Anyway, he was about 30 kilometers off, and here's a drawing of the corona that somebody drew at Cambridge, and I'm not sure where Cambridge is, and I think it's a little north of London, is that correct? I don't know. Anyway, since then there have been lots of eclipses, chases, and I want to come down to the wonderful eclipse we're going to see 2 months tomorrow. I highly recommend the website eclipsewise.com. It's wonderful. Fred Espenak of NASA is part of it, and it has a path of the greatest eclipse in Mexico, and of course it swings up through Kingston, Montreal, and out to Newfoundland. Anyway, each of these white lines is 5 minutes. Now, I'm with a group from the Mississauga Center. I'm part of both. And we're planning to drive to somewhere near Indianapolis on the Friday night. The eclipse is Monday. Then to somewhere near Memphis on the Saturday night. Then we're ready to drive somewhere near Dallas on the Sunday night. The eclipse is Monday. And we have bookings for 2 nights near Dallas. And if it turns out we have to go even further south or not even go there because it's clear up there, we're totally flexible about weather. But the whole idea is we want to go to the best place to get it. Now, this website, you can zoom it in. And I haven't done a full zoom here, but you can actually zoom in to see individual streets of subdivisions. So it's an amazingly detailed map. When you click on a spot, like my nephew and his family and 2 kids live here, it gives you the exact time totality starts to the second, but I only copied to the minute. If you unfortunately are in Oakville and can't walk a couple of miles, a couple of kilometers, you only see a partial eclipse like King Philip probably did. And this also gives the time that it's largest. And it shows very specifically where it is. And I think my friend would say that is a total eclipse prediction. And this is 3,000 years of observation and math. Thank you. Anyway, I'd love to hear some questions. Paul, are you okay? Yeah. And I hope I can answer them. This is a really big field.
It's going to be a really easy question. So lunar eclipses seem to occur a lot more frequently than solar eclipses. Is that just because there are more places on the Earth where you can see the lunar eclipse, or is there something? Is it actually a different different number of eclipses anywhere on the Earth for each time?
I think it's about the same number of eclipses. You can have partial lunar eclipses, you can have total, and you can have, I think it's called an umbral, where part of the moon is covered by the darkest and not all of it. But I think every eclipse cycle, there's at least one, with a couple of exceptions for the lunar eclipse. In each cycle, it looks like there's always a solar eclipse. That seems to be what I do. But I think it's mostly the area we can see it.
Okay.
So
Thanks.
2.5 years, you see a new lunar eclipse. It might be 4 o'clock in the morning when it's bitterly cold and windy, but there.
But if you were able to move anywhere around on the Earth, you could see it. How many? 12 times a year, or
I'm sorry, what's that?
Anywhere on the Earth? If does a lunar eclipse occur 12 times a year then?
Okay,
Or,
but a lunar eclipse could include a partial lunar eclipse.
right.
And you have, according to the diagram, you've got your Earth here, you've got the umbra that is a complete shadow, but you've also got the penumbra that goes out, and you're going to have at least a penumbral eclipse every, with a couple of exceptions, every eclipse season. Okay? And similarly with solar eclipses, it could be that the moon just nudges a little bit, takes a tiny bite into the sun, but as soon as it does that, it's called, a solar eclipse. So the total is thing, but the number's roughly the same. But the key is that not every solar eclipse is a total solar eclipse. Like those are relatively rare.
Thank you.
Okay.
Okay.
Oh, good.
It was really great. Wow, that was fascinating. Now, I have this super cool opportunity so I teach at an Indigenous school in Toronto, and I have a really cool opportunity that I'm actually taking my students to Six Nations near Hamilton. We're going to observe the eclipse. The history of the eclipse for the Haudenosaunee people is that when they started their confederacy in 1138, there was a total solar eclipse that day. So they were able to predict when it happened. Also, I'm wondering, what's the phenomena you're calling where like the eclipse keeps coming back to a path or a very similar path?
Exligmos. I'm not sure how to pronounce it, but the Saros cycle is 18 years plus a third rotation of the Earth, and 3 of those is 54 years and an exligmos. I think that's how you say it.
Thank you.
No, thanks very much, and that's fascinating. I wasn't aware of that, and I'm giving this same talk twice more, and I might, if I could talk to you after and get specific details, and I might mention it in another talk.
Any more questions? Have anything online? How about the room? No, that's it. Okay.
Can I just ask a question? How many of you are planning to see the total eclipse? I'm just curious. You're going to drive somewhere. Okay, well, I wish you clear skies. The group of us, there are 10 of us, and we decided we were going to go wherever necessary, and hopefully I'll be in luck. And I have one photographic project, and that is I'm particularly intrigued by a phenomenon I haven't seen yet, and that's the shadow bands. And they're little wavy lights before and after the eclipse. So if you're watching the eclipse, look at the ground, preferably on a sheet, before and after the eclipse, because you see these little wavy things, and they're particularly intriguing. And I was in the camera shop looking at proper cameras to take a picture. Anyway, thank you very much, and all the best. Clear skies in the eclipse.